Okay, good evening. Good morning already. This is Professor David J. Delosreyes. Okay, my new topic for my college algebra discussion for this morning will be the solution of a quadratic equation by using the so-called completing the squares. Okay, completing the squares. The first solution is actually the solution by factoring. That will be an application of the so-called special products in factoring. And the second solution prior to that is actually a solution by by extracting square roots. But this third solution by the so-called completing squares, this is just similar to the second solution. But there will be what they call this a requirement before we could find for the solution. It is by using the so-called completing the squares. Okay, let's proceed with the discussion for this morning. Okay, my discussion will be college algebra. This is now lesson number 33. So for those of you who are following my college algebra discussion, this will now be lesson number 33. We are running smooth. Okay. The title of the topic for this morning will be solution of a quadratic equation by completing squares. So there will be a concept on how to make the quadratic equation a perfect trinomial on the left hand side. Okay, let's bring out the concept on how to bring out the completing squares. To complete the square, if we are given ex square plus bx, okay, there will be an addition thing over here. We shall add to this ex square plus bx, okay, a quantity 1/2 of b over a, quantity square. For this to become a perfect trinomial, we will add we will add something like a b square over 4a square. Okay, and this will not change for any given quadratic equation. Okay, let's try to bring out an example for this one. This is a general equation. This will not change. So as long as you memorize this one, and you are only given an ex square and a bx, for this to become a perfect trinomial, we must add to it the value of b square over 4a square. Okay, example number 1. Complete the square and write the trinomial in factor form. There is a word trinomial over here. Sorry for that one. I will be using the green one. Trinomial. What it means is that after the addition of b square over 4a square to the value ex square plus bx, what will come out will be a trinomial. It involves 3 terms, right? And the problem is asking, after the trinomial come out, right? We shall bring out the factor form. Okay? We are not even computing for the value of x for the meantime. We are just only completing the squares. Okay, the given problem for example number 1 is 4x squared plus 9x. Okay, so this is of the form ex squared plus bx. Okay, first step, we'll try to make the coefficient of x squared unity or simply 1. So we divide all terms by 4. So 4x squared, or we just multiply this by 1/4 to be more specific. By 1/4. Right? Multiplication. So 4x squared times 1/4, it will be x squared. 9x times 1/4 will be 9 over 4x. Okay, so after the division of the value 4 for all the terms, what comes out now will be an x squared plus b over a x. Okay, and I place it here. For this equation here to become a perfect trinomial, we will add to it the value b squared over 4a squared. Take first 1/2 of the ratio b over a, then try to square that one. Then you will add this one to this. Okay, so for the given problem, we will add 1/2. The ratio b over a is 9 over 4, right? So this is 1/2. Open bracket 1/2 times the quantity 9/4 close bracket. Okay. Oh, is it correct? We shall square it. There is no square. Right? 1 times 9 is 9. We square it, it will be 81. 2 times 4 will be 8. We square it, that will be 64. So meaning to say, the constant that must be added to this given equation here should be the value 81 over 64 for it to become a perfect trinomial. Right? So we will rewrite it, x squared plus 9 over 4x plus 81 over 64. Okay? This is now actually the trinomial that will come out. And this is now factorable to the quantity. Okay? That's why the problem says put it in factor form. After the coming out of the trinomial, factor it, right? So this should be the product of quantity x plus 9 over 8 quantity squared. So this will be the final answer. Okay? What comes out now will be a perfect trinomial, and this is now factorable to the quantity x plus 9 over 8 quantity squared. We could check it. The square of x will be x squared, right? The middle term will be x times 9 over 8. I'm covering the board. 9 over 8x multiplied by 2. That's the middle term, right? And the pure constant term will be the square of the last part. That will be plus 81 over 64. Okay? So this is x squared. This is 81 over 64. And the middle term, this one here, cancel with this will be 4. So the middle term will, after the cancellation, it will be 9 over 4x. And this 9 over 4x is actually this one. Okay? So meaning to say, after the addition of 1/2 of the ratio b over a, we square it, what comes out will now be a perfect trinomial. And this is now factorable to the quantity x plus 9 over 8 quantity squared. Answer. Okay? We are not even solving for x here. We are just completing the square. Right? Example number 2. Complete the square and write the trinomial in factor form. The given quadratic equation is a 3x squared plus 2x. Okay? We are to bring out a trinomial over here. There should be a trinomial. Then we try to factor out. Right? So the first step is we must have to eliminate the coefficient of x squared. No, eliminate. Make the coefficient of x squared unity. And to do that, we will multiply all the terms by 1/3. Multiply. Okay? So this 3 here will disappear. Cancel with this, right? It will be x squared. 2x times 1/3 will be 2 over 3x. And this form here is now similar to this. Right? So the added constant for it to become a perfect trinomial, I place it here, add 1/2, okay, of the ratio b over a. 2 over 3 quantity square. But we could cancel this 2 here, right? So the numerator will just be simply 1. So 1 square will be 1. The denominator will be 1 times 3. We square it, it will be 9. So meaning to say, the added pure constant, which must be added to this, for it to become a perfect trinomial, it should be 1, 9. So this is now x squared plus 2 over 3x plus 1, 9. That's the trinomial now. Okay? Contains 3 terms, right? And this is now factorable to the quantity x plus 1/3 quantity square. Again, if you try to check it, just expand this one and let us see if the expansion will come out to be this trinomial. The square of x will be x squared, right? The middle term will be x times 1/3 times 2. The middle term will be x times 1/3 twice, right? And the last part will be the square of 1/3, which is 1, 9. Or what comes out? The first term is x squared, this is x squared. The last part is 1, 9. And the middle term is actually, 2/3 x. 2/3 x. Okay? Because 1 times x is x, 2 is on the numerator, this times 2. Denominator is, the 3 is under the denominator. So the middle term after the expansion is 2/3 x, and this is same as this one. So meaning to say, after the addition of 1, 9, this will now be a trinomial, and this is now factorable to the quantity x plus 1/3 quantity square. Answer. Okay? We are not yet solving for x. Okay? We are just practicing on how to convert a given quadratic equation to a perfect trinomial. So we could take the so-called factor form of that one. Okay, the next part of the lesson will be solution of a quadratic equation by completing squares. By completing squares. Okay, we shall bring out the solution of a quadratic equation by completing squares. Actually, the quadratic formula emanates from the solution by completing squares. But for tonight, we'll do first the solution by completing squares, and the next lesson will be a solution by using the quadratic formula. We will derive the quadratic formula by using the so-called completing squares. But for tonight, we will be presenting a solution by completing squares. Okay, example number 1. Solve by completing the squares. We are given the quadratic equation, x squared plus 7x plus 12, and this should be equal to 0. As usual, we transfer all constant terms to the right? So what comes out will be x squared plus 7x. We transpose this to the right, this should now be negative 12. Okay? And this form here now, sorry for that one, it is similar to the form ex squared plus bx. Okay? From the previous two examples, we know how to complete square, right? So, x squared plus 7x, for this one to become a perfect trinomial, we use our knowledge from example number 1 and number 2. So, we will add 1/2, okay, of the exponent of x. 1/2 of 7, we square that one for it to become a perfect trinomial, this one. And 1/2 of 7 will be, the square of 7 will be 49, and the square of 2 will be 4. So the added constant on the left, for it to become a perfect trinomial, should be 49 over 4. So adding 49 over 4 to both sides, x squared plus 7x 49 over 4 equal to negative 12 plus 49 over 4. Okay? You add something 49 over 4 to the left, you add 49 over 4 to the right. Okay? We can do that. It will not change the value of the equation. Then try to combine the left hand side. the left hand side now will become a perfect trinomial square, or perfect trinomial. It will be, this is now factorable to the quantity x plus 7 over 2 quantity square. Okay, if you try to expand this will come out. That's why I presented example number 1 and number 2, so we know this for sure here. So this is now factorable to x plus 7 over 2 quantity square equal to negative 12 plus 49 over 4. Okay. There should be an over 4 over here, right? Then times 4 up. So we could add immediately. So negative 12 times 4 will be negative 48 plus 49 over the common denominator 4. 49 minus 48 is 1. 4 is actually 2. So we close quantity this one, this is raised to the second power. Okay? And the next step now is actually the last topic, that is by taking the square root of both sides. Okay? So we rewrite it, and we raise that to the 1/2 power, because the enemy of a 2 will be 1/2. So if we try to expand this one, this 2 here cancel with this, and this 2 here cancel with this. So what remains on the left will be x plus 7/2, no more 2, because there is a 1/2 here, right? And the square root of 1/2 of square will be, this is now greater than 0, right? So what will come out for the square root, if it is greater than 0, it should be plus or minus 1/2, right? So by using the positive sign, x1 now will be equal to 1/2. By using the positive sign of this, we place this on the right, minus 7/2. Okay. Same denominator, so 1 minus 7 will be minus 6, all over a common denominator 2. So x1 now will be negative 3. Using the negative sign, we are through with plus 1/2, right? This is actually plus 1/2. Negative 1/2, next one. Minus 7/2. Okay. We are adding two fractions with different denominator, and luckily the sign is negative, right? So a negative 1, negative 7 will be negative 8, all over a common denominator 2. So we are using actually our knowledge of fundamental operation. Okay, minus 8 over 2, x2 now will be negative 4, answer. Okay, so that's the solution by completing squares. Okay, without knowing example number 1 and number 2, we could not bring out the solution by completing squares. Because we should know what to be added on the left for it to become a perfect trinomial. Oh, last example for this morning. Solve by using completing squares. We are given the quadratic equation, 3x squared plus 5x minus 2 equal to 0. Okay? Solution. 3x squared plus 5x, we place this on the right. This should now be positive 2. Okay? The left hand side after the transposition is of the form ax squared plus bx. Right? And as I have said, for this to become a perfect trinomial, we will take 1/2 of the ratio b over a. Okay? Then we raise that to the second power. That is the value of the constant to be added on the left for it to become a perfect trinomial. So I will bring it out here after. Okay, hold on. We multiply first this one by 1/3. Okay? 3x squared times 1/3, it will be x squared. 5x times 1/3 will be 5/3 x. Right hand side will be 2 times 1/3 will be 2/3. So after eliminating or converting the coefficient of x squared to be 1, okay, we'll complete the square on the left. So we will add 1/2 of the ratio 5/3. We square that one. 1 times 5 is 5. We square that one, that will be 25. Right? And 2 times 3 will be 6. We square that one, it will be 36. So the constant to be added on the left, for it to become a perfect trinomial, should be the value 25 over 36. So this will now be x squared plus 5 times x plus 25 over 36 equal to 2 over 3. We add 25 over 36. Okay? We add this one on the left. We add this one on the right. We are not changing the value of the equation. Okay? And this is now factorable to the quantity x plus 5 over 6 quantity square. If we try to expand this one, this will be the expansion. Perfect trinomial, this is the factored form. What we did on example number 1 and number 2. And they should not be equal to. The right hand side is 2/3 plus 25 over 36. But the denominator of this is 3. So for us to combine it, the denominator should be 36. So we multiply the 2/3 by 12 over 12. So 2 times 12 will be 24 plus 25. The common denominator now will be 3 times 12, which is 36. Okay, 24 plus 25 is 49. This is over 25. And they are both perfect square. The square root of 49 will be 7. Square root of 25 is 5. So 49 can be written as the ratio 7 over 5 quantity square. So the right hand side is actually 36. Sorry, this one, 36. Should be 36. So this should be 6. So the ratio 49 over 36 can be written as a perfect square to be 7 over 6 quantity square. Then raise both sides of the equation to the 1/2. That's actually solution by using the so-called square root method. Okay? We raise all both the left and right to the 1/2. So these two here cancel with this, and these two here cancel with this. So what remains on the left will be x plus 5 over 6 equal to. On the right hand side, the sign of the radical is actually plus and it is greater than 0. So the resulting, what you call this square root, will either be plus or minus. So this will be, or can be written as plus or minus 7 over 6. By using the positive sign, x1 will be 1/3. Okay, 7, 6 minus 5, 6. 7 minus 5 is 2, all over the common denominator 6, and we divide it by 2 again, so x1 will be 1/3. By using the negative sign, negative 7 over 6 minus 5 over 6, okay, and this should now be negative 7, negative 5 is negative 12, all over the common denominator 6, so x2 now will be negative 2. So this will be the second answer. That will be the first answer. It's very easy, right? And you've been seeing problems or on YouTube on the shorts video regarding the so-called completing squares. Okay? So if you are good in the so-called solution of a quadratic equation in the completing square, you will be very good in college algebra. Okay, so for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. I'm telling you this one. Try to watch my long video format discussion on college algebra. You will learn something from it. And for those who are not, who don't know yet that I have finished other 4 subject matters, I am done with differential calculus. I am done with integral calculus. I am done with differential equation. I am done with advanced math. So if you want to watch a long video format discussion on differential, integral, differential equation in advanced math, try to go to my channel. My channel is at youtube.com/@ProfDavidJDelosReyes. Okay, good morning from Los Angeles. Thank you very much.